Multivariable linear systems. So yesterday we talked about linear systems that had two equations with two unknowns, x and y. Today we get to revisit the equations you know and love from Algebra 2, three equations, three variables, x, y, and z. So now we're in the third dimension. So if we're solving this system, which is in row echelon form, here's a new word for you, row echelon form. Notice how it's all nice, neat, diagonal. Two variables eliminated, one variable eliminated, no variables eliminated. That's row echelon form. If you can get an equation with three variables, three unknowns into that form, it can save you a lot of work. Okay? So, how are we going to solve the system of equation, Brian? Absolutely. So y plus 2 equals 3, and I would be careful with z's. Put a little dash in them so you don't confuse them with 2's. Okay? So what's y? Y is 1. Now what? Plug them both into the first. So x minus 1 plus 2 times 2 equals 1. So x 4 minus 1 minus 3 plus 3 equals 1. So what's x? Negative 2. How do we write our final answer? As an ordered triple, negative 2, 1, 2. X goes first, then the y, then the z. Okay? Easy enough, right? Unfortunately, they won't all be that easy. But when they're in row echelon form, they are. So we're going to work on putting them in row echelon form. So it's not just a random, I'm going to try this and see if I get somewhere. Okay? So everybody's done with first slide? Second one. Must have clicked twice. All right, so we're going to solve by Gaussian elimination, putting it in echelon form, basically. Okay? So the idea is first to eliminate one variable from both equations, and then to eliminate the second variable from both equations so that you can find out what all three are. So I'll show you. We're going to use this top equation to eliminate the x in the second equation. So top equation is going to be taken times negative 2. Okay? So if I take this times negative 2, put it down here, I'll have a negative 2x plus 3y, 6y, and a minus 4z. Don't make the mistake of not carrying through to the constant. Negative 2 times a positive 1 is a negative 2. And then I'm going to add it to the second one. So negative 2x and a positive 2x, gone, which is our goal. Negative 5y and a positive 6y, 1y. Positive z, negative 4z, negative 3z. Negative 5, negative 2, negative 7. Now we repeat the process. This time, though, we're taking the top one times a number to eliminate the x's in the third equation. So what are we taking the top one times? Negative 3. So if I take this times a negative 3, I will get negative 3x, positive 9y, negative 6z, and a negative 3. I'm going to add that to my third equation. X's go away. 9y plus 1y, 10y, negative 6z and a negative 2z, negative 8z, negative 3, negative 1, negative 4. Make a mistake? No? All right. Then the last thing that's going to make this easy on us is we're going to do the same thing one more time, but now we're trying to eliminate the y's. So we only have z and we can work our way backward. So we're going to take this first equation times what to eliminate y's? Negative 10. So we'll have a negative 10y, a positive 30z, and a positive 70. Y's are gone. We get 22z and 76 minus, or 70 minus 4, 66. So z becomes 3. Yes, sir. Nope, I added it to this one. Okay, so, okay, give me a second. Let me start over. I should have probably done this in different colors. So premise was we want to eliminate x's first. So we took our top equation times a negative 2 and we added it to this guy. So negative, it went down here. We added these two together to eliminate a y, or an x, and we only had y's and z's. Then we took our top equation times a negative 3 to eliminate the x's again, adding the top and the bottom one. And that eliminated the x's again. And now we want to eliminate the y's, so we take this new equation with no x's and times a negative 10 to get rid of the y's, and now we only have a z. Yep, whatever you'd have to multiply it by to add it to each of these to eliminate the x's. Everybody okay so far? All right, so now z is 3. So let's make our life easy. Pick a good place to put it into. I'd probably recommend this equation right here. We're going to put 3 in for z. Okay, so y minus 3 times 3 equals negative 7. Negative 3 times negative, or times a positive 3 is negative 9. So when I add 9 to both sides, y becomes 2. Yep, positive 2. And now I know what y and z both are, so I'm going to pick an easy equation to plug it into. It doesn't matter which one. We should get the same result no matter what. Let's put it in the top one. X minus 3 times 2 plus 2 times 3 equals 1. So x minus 6 plus 6 equals 1. So now we have an ordered triple. X always gets written first, then the y, then the z. Everybody good with the process? We just see another one. Yes. We don't have to work it all the way out, maybe just until we get partway there, and then we're good. So let's do one more. Solving by Gaussian elimination again. Okay. A lot of writing. X plus y plus z is 2. 2x plus 3y plus 4z is 5. And x minus z equals 1. So we're going to eliminate x's. make them A, B, and C. What do I want to take A times to eliminate B, the X and B? Negative 2. So we're going to take A times negative 2 and add it to B. So A times negative 2 will be a negative 2x minus 2y minus 2z equals negative 4. Just transferring this b over. 2x plus 3y plus 4z equals 5. Adding them up. Gone. Y plus 2z equals 1. Okay. Now I want to eliminate x's again. Keep the pattern the same. What do I multiply a by, or a by, in order to make c go away? Negative 1. So it's going to be a times negative 1 plus c. So negative x minus y minus z equals negative 2, added to 2x plus 3y plus 4z equals 5. Sorry, I wrote the wrong one. Second, the third equation, my fault. X minus z equals 1. X's are gone. Negative y plus 2z equals negative 1. Minus 2z, my fault. And of course, I have to set this down and completely erase. Yes. Okay. What happens when we add these two up? They cancel. Y and negative y is 0. Positive 2z, negative 2z, 0. 1, negative 1, 0. Is that a true statement? 0 equals 0? Yeah, anytime you get a true statement, 17 equals 17, negative 5 equals negative 5, 0 equals 0, that means that you have what? Infinite number of solutions. They're consistent equations. They're the same line. Okay? All right. Non-square systems by Gaussian elimination. Why do they call this non-square? Not a 3 by 3, very good. And remember that terminology, we're going to use that next chapter. Okay? We're missing an x, y, and z. We're missing a third equation, aren't we? So there's not going to be a unique solution, a true ordered triple. Okay? So I'm going to take my top one times a negative 3. Perfect, let's do that. Okay, let's do that instead. Instead of using Gaussian elimination, let's just eliminate the z's by adding them up. 4x plus y, z's are gone, equals 6. Okay. Now what? So y is equal to a negative 4x plus 6. So 3x plus 5y minus 2z equals 0. So 3x plus 5 times this negative 4x plus 6 minus 2z equals 1. So we have a 3x plus a negative 20x plus 30 minus 2z equals 1. Negative 17x minus 2z equals negative 29. Now we just have x's and z's, don't we? Instead of y's and x's. Solve for x on that one. We're going to run around in circles, aren't we? Jeannie suggested we add these two up because the z's will go away. And we only had two variables then with two unknowns. Okay. Look through assignments on my site. I'll pull it up real quick. Look through the example on page 6. Okay. Try to do as much as you can and look through the example on the page. Example 6 in this section.